Hello class 11 science. In our last class we have seen law of multiple proportion and law of reciprocal proportions. Now today we are going to see the fifth law of chemical combination, that is Lussac's law of combining volumes or gaseous volume. This law you have studied in class 10 as well in the chapter mole concept. Once again, according to the law, it states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the gaseous product, provided that all the volumes are measured at the same temperature and pressure. This is the statement, and this law is valid for only gases, reactants and products, and the volumes of solids and liquids are considered to be zero. That you need to know while studying this law. Now for explanation of this law, what the statement explains us. So say for example, if you take an example of hydrogen and chlorine reacting with each other to give you HCl, hydrogen chloride. Now we'll write down the equation. We'll write down the balance equation, and after that we'll see. Say for example, in hydrogen we have got only one molecule. In chlorine also we have got one molecule, and in HCl we have got two molecules of HCl. So considering the volume, it will be one volume, and this is two volume. Now according to the Lussac law, when gases react, because both are gases, hydrogen and chlorine, they do so in volumes which bear a simple ratio to one another and to the volume of the gaseous product, provided that all the volumes are measured at the same temperature and pressure. That means the conditions that over here you need to maintain is you have to keep the same temperature and pressure. So at that time what will happen, the ratio of the volume of the reactants and products, that is H2 is to Cl2 is to HCl, will be 1:1:2. This is the ratio of their volumes, which is a simple ratio. Similarly, we'll take another example. Nitrogen reacting with hydrogen to form ammonia. This is a very important process for the manufacture of ammonia, and it is known by a name known as Haber's process, if you know. So here also same volume, one volume of nitrogen, and over here we have got three volume of hydrogen and two volume of ammonia. So here also if you find the volume ratio of nitrogen, hydrogen and ammonia, it will be 1:3:2, which is also a simple ratio. So this explains the law of combining volumes, or we also call Lussac's law. Next topic we have got it atomic mass and atomic weight. This topic also we have already studied from class 8, 9, 10. So once again, atomic mass of an element is the number of times one atom of the element is heavier than 1/12 atom of carbon, having atomic mass 12. So atomic mass is given by mass of one atom of the element divided by mass of 1/12 atom of carbon. That means atomic mass of any element is defined as by how many times it is heavier than one atom of an element. Atomic mass has no unit since it is a ratio of the masses. Gram atomic mass. Atomic mass of an element expressed in gram is known as gram atomic mass. Say for example, atomic mass of carbon is 12. In the gram atomic mass of carbon will be 12 gram. Similarly, we have got another term, molecular mass or molecular weight. This also we can define similarly as atomic mass. The relative molecular mass of an element or a compound is the number that represents how many times one molecule of the substance is heavier than 1/12 of the mass of an atom of carbon 12. So molecular mass will be given by mass of one molecule of a substance divided by mass of 1/12 atom of carbon.